In this lecture, we will introduce networking.
One of the biggest innovations recently is the computer network. So what is that? Well, it's basically a set of independent computer systems connected by telecommunication links for the purpose of sharing information and resources. Now, the individual computers themselves are referred to as nodes, or sometimes also referred to as hosts, and they can range in size. They can be smartphones, tablets, tiny laptops. They can be massively large parallel supercomputers. So what we're going to do here is we're going to describe some of the technical characteristics of the network. We'll start by discussing the communication links that are involved in a network. The communication links used to build a network vary widely in physical characteristics, error rate, and transmission speed. In the approximately 45 years that networks have existed, telecommunication facilities have undergone huge changes. In the early days of networking, the most common way to transmit data was using a switched dial-up telephone lines. And the term switched dial-up means that when you dial a telephone number, a circuit or a path is temporarily established between the caller and the callee. And this circuit will last for the duration of the call, and then when you hang up, the call is terminated. Now, this voice-oriented dial-up telephone network, which was originally set up as an analog medium. So here we would represent the sound as in waves with an amplitude and a frequency. So, this was fine for transmitting human voice because it varies continuously in pitch and volume. But a computer produces digital information, specifically a sequence of zeros and ones. So in order for us to be able to transmit this stuff through a telephone line, we need to be able to restructure these binary numbers into an analog representation. And this is where a modem comes into play. This is the device that actually modulates or alters a signal to include the binary information. So we would actually translate this digital signal into an analog signal. And this resulting signal was called the carrier wave. So the modem would modify the physical characteristics of the carrier wave, such as the amplitude or the frequency, so that it is in one of the two distinct states that represents binary. So one state would represent 0 and the other state would represent 1. And then at the other end of the transmission, a second modem would perform the inverse operation. And this is what's known as demodulation. So the idea is it would take the received waveform, separate the carrier from the encoded digital signal, and then pass the digital data onto the computer. Now, initially, dial-up connections were really slow. These analog encoding and decoding operations couldn't be done very quickly, just because of the high error rate and the low capacity of a switched telephone line. When we mean by capacity, we use the term bandwidth nowadays. In the early days of telecommunications, these dial-up connections had a transfer rate of about 1200 to 9600 bits per second. That is really slow, especially compared to today's connection speeds. Now, there were advances in the dial-up modems, and they could transmit at 56,000 bits per second, or 56 kbps. And so, this was better, but it's still way too slow to handle the transmissions of multimedia-based documents, such as web pages or MP3s or videos. Now some of these connections are still used for things, but we really don't see 56K modems being used anymore. There was some recent technology called the broadband that's rapidly replacing modems and analog telephone lines for data communications to and from schools, homes, and offices. The term broadband generally refers to any communication link with a transmission rate exceeding 256,000 bits per second, or 256 kbps. So in the case of home users, there are two currently widely available broadband options, which we call the digital subscriber line, or DSL, and the cable modem. A digital subscriber line, or DSL, uses the same wires that carry regular telephone signals into our homes. and therefore it's usually provided by your local telephone company. Now, although it uses the same wires, a DSL signal uses a different set of frequencies, and it transmits digital rather than analog signals. So therefore, the voice traffic that's generated by talking with a friend on the phone doesn't interfere with going onto a website or just really using the internet at all. So you can talk to someone on the phone and use the internet at the same time. Also, unlike the modem where you have to explicitly establish a connection, so you would dial a number with the modem and then end the connection by hanging up, a DSL is a permanent always-on link. So there really isn't any need for dialing and waiting for a circuit to be established. So you don't have to worry about calling a number, and you don't have to worry about hanging up when you're done using the internet. It's just always on. Now, DSL is often asymmetric, which just simply means that it does not have the same transmission speed when we download stuff compared to when we upload things. And this kind of makes sense because we're usually downloading stuff more than we're uploading anything. I mean, anytime you visit a web page, you are downloading that page. So you really don't do a lot of uploading. Typical DSL speeds are about 5 to 15 million bits per second, which we denote as Mbps or megabits per second. And then upload speeds are usually around 1 to 2 megabits per second. And this is still a lot faster than dial-up modems. The second option for broadband communications is the cable modem. And this technology makes use of the links that deliver cable TV signals into your home. So it's offered by cable TV providers. Some of the link capacity previously allocated for TV signals is now used for data communications. And just like DSL, a cable modem also provides an always-on link and offers speeds slightly higher than those available from DSL. So, for example, usually we have about 10 to 20 megabits per second for downloads and maybe 1 to 3 megabits per second for uploads. In the commercial and office environment, the most widely used broadband technology is Ethernet. Now, Ethernet was developed back in the mid-1970s, and it was originally designed to operate at 10 megabits per second using coaxial cable. However, there were some problems with this. This was just too slow for many applications. So in the early 1990s, researchers developed a new and improved version, which is called Fast Ethernet, and this transmitted at 100 megabits per second across coaxial cable, fiber optic cable, or even regular twisted pair copper wire. But even then, they weren't happy with 100 megabits per second. So researchers were investigating the concept of gigabit networking, where transmission lines would support speeds of 1 billion bits per second, or 1 gigabit per second. So in the early 90s, the US government funded a long-term research project, and one of the goals was to investigate the design and implementation of wide-area gigabit data networks. And this was successful. So researchers were investigating this idea of a gigabit Ethernet, and they came up with the gigabit Ethernet standard in 1998. So the whole point here was that it supports 1,000 megabits per second, or 1 gigabit per second. And this was a huge result. So I mean, most machines now are built to have this Ethernet interface and be able to support these types of connection speeds. But even then, they weren't happy with 1 gigabit per second as the end result. So a new standard in 2003 was released that supported the 10 gigabit Ethernet standard. So this was a version of Ethernet with a data rate of 10 billion bits per second. And so that standard was adopted. And I mean, that's really fast. And now they introduced another standard in 2010 that was for 100 gigabit Ethernet. And here we're talking about transmitting data at almost unimaginable speeds. We're talking about a rate of 100 billion bits per second. So it's a little unrealistic now, but it is something that we are currently working on. An extremely important development in the field of telecommunications is this rapid growth of wireless data communication. So the whole point here is that we can send signals and receive signals without using any physical wires. So just to give a couple examples, we can use radio waves, microwaves, infrared signals. So the whole point here is that users would no longer need to be physically connected to a wired network in order to access data. So we can include these in laptops, tablets, phones, and so forth. But now we can connect everything wirelessly, so we don't have to manually plug in our machine into a network in order to access data. Now, there are two forms of wireless data communications. We have the wireless local area network, which we denote as a WLAN, and then we have a wireless wide area network, which we denote as a WWAN. In a wireless local area network, a user will transmit from his or her computer to a local wireless base station, and this is often referred to as a wireless router that is no more than a few hundred feet away. Now, this base station is then connected to the traditional wired network, such as the DSL or a cable modem, to provide the full internet access. This type of wireless configuration is typically found in a home, library, office, or even a coffee shop because it's cheap, it's simple, it's low powered, and it's very easy to install. One of the most widely used standards for wireless local access is called Wi-Fi, which is short for wireless fidelity. So Wi-Fi is used to connect a computer to the internet whenever it's within range of a wireless base station. And usually this is within like 150 to 300 feet. In fact, most businesses will advertise that they have Wi-Fi hotspots, which is basically a router. Is really all this we're talking about here. Now, Wi-Fi systems generally use the 2.4 gigahertz radio band for communications, and they support download speeds of about 10 to 50 megabits per second, which is pretty good for wireless. Researchers are currently looking at trying to use higher radio frequencies to support high-speed gigabit Wi-Fi communication. Now, there is a relatively new development in wireless networking, which is called metropolitan Wi-Fi service. And so here what we have is a number of cities that would provide Wi-Fi routers that be installed every few blocks throughout that city. And usually this is on top of telephone poles or building roofs. So these routers would provide convenient, low-cost wireless internet access to all residents in that city. And there is a third popular wireless standard, which is called Bluetooth. I'm sure you've heard of Bluetooth. I'm sure you've used Bluetooth. The idea with it is it's a low power wireless standard that's used to communicate between devices located quite close to each other, usually no more than 30 to 50 feet. Now, Bluetooth is often used to support communication between wireless computer peripherals such as printers, mice, and keyboards, and a laptop or desktop system close by. They also support information exchange between digital devices such as mobile phones, cameras, and even video game consoles. So like a really good example is most vehicles now support Bluetooth with phones. That way you can talk with someone hands-free without actually having to use your phone. Now, Wi-Fi is great for communicating with a nearby router, but it does have transmission limitations because, I mean, you cannot provide mobile internet access from a car or from an outdoor site from any base station. So, I mean, if you're too far away from the base station, then you can't connect to the internet. So to handle this type of wireless communication, we need a different type of network. So this is the second type, the wireless wide area network, or the WWAN. So in this type of network, the computer, which is often a tablet or a smartphone in this case, transmit messages to a remote base station provided by a telecommunications company. And this base station may be located many miles away. Now, these base stations, I mean, it's usually a large cellular antenna placed on top of a tower or a building. So this will provide both long-distance voice and data communication services to any system within sight of that particular tower. So just as an example, one of the most popular wide area wireless technologies is called 4G. So it offers services as well as data communication at rates of maybe 5 to 20 megabits per second. And this is pretty good compared to DSL or cable modem. And there are other WLAN technologies such as WiMAX and LTE. Now it's the same. I mean, there are some issues with it. So I mean, you have to make sure that you're in line of sight of the signal. I mean, how many times have you been on call with someone and then your signal dropped or your call dropped because you didn't have a signal? So I mean, you do have those limitations, and also it's not that difficult to intercept wireless transmissions. They're not as secure as normal network transmissions. So you have to be very careful with what kind of data you actually send over the wireless network.